Hello and welcome everyone for the lesson 4, that is graphing rational functions. I hope you recall the last lesson, that was reciprocal functions. There is a little bit of difference in rational and reciprocal. Now we will look into the learning objectives. They are to graph and analyze rational functions with vertical and horizontal asymptotes, and then to graph and analyze rational functions with oblique asymptote. Now if you look into the first objective, we had vertical and horizontal asymptotes in the previous lesson in reciprocal functions. This oblique asymptote is something different which we will study in this lesson. The keywords are rational function, oblique asymptote, and point discontinuity. These are all occurring. Oblique asymptote and point discontinuity occurs only in rational functions. Now then, we will look into the difference of rational functions. If we recall, the reciprocal function was the last lesson, f of x equals 1 by any function a of x, provided this was a linear function. Here you can see there is a function in the numerator and denominator, and it's a polynomial. It can be any degree. It's not just linear, it can be power 1, 2, 3, 4 or anything. So these are rational functions. It's like ratios of two functions. Now there are some conditions. Instead of going through all this, I'll just point out three important conditions. Now, when does the horizontal asymptote occur? Now we know the vertical asymptote is whenever the denominator is equal to 0, just like the previous lesson. Now the horizontal asymptote, it's not like something is added over here like reciprocal. Here we need to see the functions. What is the equation? What's the degree of each terms? So now if at all the degree of the above term is greater, say now it is 7 and over here we have x power 2. In such cases, there is no horizontal asymptote. If this is the axis, there is no horizontal asymptote. It's only vertical. Now, if this is the condition 1, if the degree is less, now for example, the above degree is less than the denominator, say this is 5, then doesn't matter what, the horizontal asymptote will be at y equals 0. If you see this is the point 0 point, here there will be an horizontal asymptote. This is the condition 2. And the last condition is if the degrees are same. What about the degrees are same? 3 and over here we have 2x cubed, x power 3 and divided by 2x cubed. And if you have any other term, that's fine. All you need to look at is the highest degree. It's power 3, over here power 3. Write the coefficients. Over here what's before it? It's 1 and over here it's 2. The horizontal asymptote will occur at this point, and this is the third condition. It'll be easier when we'll solve problems. Now let's jump into the problems. Here you can see there is x cubed in the numerator and x plus 2 by 3 in the denominator. Now looking at this, you can understand the numerator is bigger than the denominator by a lot. So there is no horizontal asymptote. In the graph, we won't have any horizontal asymptote. That line horizontal. So now what do we do? See, the steps are very simple. Find the zeros. What does 0 mean? 0 is the solution of the graph. Imagine we have a graph like this. What are the zeros? Zeros means x-intercept, wherever the graph touches the x-axis. This one, and this one. All these are the zeros. Okay. So now how do we find it? It's very, very simple. Just equate the numerator equal to 0, you will find it. So when you equate over here, a of x, that's the numerator, x is 0. So take cube root on both the sides, you will get x equals 0. Cube root of 0 is 0. Now what about the next step? So 0 is at x equals 0. That is the x-intercept. Now what about the y, the denominator? This gives you the vertical asymptote. So in order to find the asymptote, the vertical asymptote is always by the denominator equals 0. First step was numerator equals 0. Second is denominator equals 0. Now solve it. X plus 2 by 3 equals 0. Take this to the other side. X equals negative 2 by 3. That's it. So the answer is x equals negative 2 by 3 or 0.666. So this is the vertical asymptote and negative down the x-axis. So now then we have got the zeros, vertical asymptote. Does this have a horizontal asymptote? No. The degree in the numerator is greater than the denominator, so no horizontal asymptote. And now all we need to do is graph. Now this graph needs to be done by the table of values. Basically, you need to get some values. See, it's easier. How you need to graph is it's easier to remember this x value. Okay, where is the vertical asymptote? At negative 2/3, right? That is negative 0.66. So take values less than that and more than that. Okay, if it's close, see, negative 2 by 3 is close to 0. So just take some values over here. So negative 2, negative 1, 0, 1, 2. Now, if you put these values of x in this equation, over here you will have to put negative 2 bracket cube. Don't forget the bracket, you'll get wrong answers. And over here it's negative 2 plus 2/3. If you put this, you will get the answer 6. And same way, put the other values. Okay, if you put over here 0, numerator is 0, that entire term is 0. And similarly, do put the others and you'll get these answers. So once you get these answers, you can plot this graph. Now over here, there is no horizontal asymptote. There is no horizontal line, dotted lines, only vertical at negative 0.66. So this is the vertical asymptote, and then you just graph few points. Now, if you're thinking, okay, how will I know this exactly? It's fine. You know, you're not gonna graph this accurately. You can just understand, okay, this is near the asymptote. This is near the asymptote. So just mark few points and just connect them, and don't touch the asymptote. If it's asymptote and you got a point like this, so it will be something like this. It'll go near, but it will not touch it. Okay, sorry, that's not very good. So now imagine the line is like this. Just draw a line. Don't touch it to the asymptote because it never touches the asymptote. It looks as if it's touching because it's very close by, but just keep that in mind. Now over here we have a check problem. How do we solve this? First of all, they want to find zeros. That means the numerator equals 0. Take cube root on both the sides. You will have 0.5x minus 1 equals 0. So take it to the other side. It will be half. 0.5 is half. X equals 1. Take half to the other side. It's 1 by 2. It will be x equals 2. 1 divided by 0.5 is 2, or 1 by 2, right? Half. 2 goes to the other side. X is 2. So the 0 is at 2. Now what about the vertical asymptote? Just make this equal to 0. X equals 0. So that's it. And now graphing the function, you need to take some values. First of all, this vertical asymptote is very important to be drawn, and you see there is no horizontal asymptote because the higher degree, the degree in the numerator is greater than the denominator. Now here, take some points. Say you can take -1. If you take 0, it doesn't make sense because it's undefined, so avoid 0. -1, -2, 1 and 2. Plug the values over here. Instead of x, put it as -2, -1, 1 and 2, and put in the calculator, and then you will get the graph. Some points you'll get, just plot them and you will get the graph. So that is it. So you won't be accurately able to guess this is the steep, see the curve is like this. Just whatever is possible, just graph it. Mainly these values are important. Now here we have a real world problem. Use graphs of rational functions. Now, pharmacy, related to pharmacy, it's Young's rule can be used to estimate the dosage of medicine to give a child if you know the adult dosage of the same medicine. Young's rule can be written as y equals ax by x plus 12, where a is the adult dosage in milligrams and x is the age of the child in years. So now, if you're sick, the medication what adults and say children take are different. Now if you're in your teen or say 15, 16, you might take adult dosage, it's fine. But if you're very young, say 4 years, 3 years old child, or depending on the age, the medicine varies, so the dosage, in the sense the milligram of the chemical. So that's why this particular formula is used. So this is the main concept behind this. Now here they have given some conditions and we need to solve accordingly. Here they have asked to graph the function initially, and then when do we have to graph? Where the adult dosage is 200 milligrams, where A is the adult dosage, right? A is 200. So how do we graph? So here, instead of A, you have 200 given in the question. It'll be y equals 200x divided by x plus 12. And now solve the vertical asymptote. What is the vertical asymptote? It is whatever is the denominator equals 0. X equals minus 12. Take it to the other side. But now look carefully. What about the degree over here? It's 1 and 1. It's equal. In such cases, what is the asymptote? Horizontal asymptote. We have horizontal asymptote. See, write the coefficients. It's 200, and over here x, there's nothing, so it's 1. So y equals 200. So the horizontal asymptote is at 200. Okay, this is the answer. Now we know the horizontal and the vertical asymptote. See over here, this is the horizontal 200, vertical was at minus 12. So this is minus 20, so this is about minus 12. The scales are different in both axes, and this is how you graph it. Now, how do you graph the remaining part? See, if you just take 1 or 2 points, so before this, before the vertical asymptote, take a few points, put it in this equation. Instead of x, say put minus 40 or plus 40, and then you will get the graphs. Okay, so this is how it works. And now find the key features. What are the key features here? Now, one more thing, if you look closely in this graph, let's just look over here. The domain is mainly from 0. See, at 0, if it's 0 age, 0. As the age increases, you can see the dosage increases. Okay, there is a variation. As you increase, the dosage keeps on increasing. So as the age increases, x value age, the dosage particularly increases. Now then, here, find the x and y intercepts. They have told to find in the part B. So how do you find x and y intercept? Always remember, for x intercept value, y is equal to 0. Whereas for y intercept, x equals 0. All you need to do is substitute in the calculator. That's it. Here, let me solve for x intercept by equating y is equal to 0, and then remaining values are as it is. It's 200x divided by x plus 12. Take this to the other side, it becomes 0 equals 200x. Divide both the sides by 200, it will be 0 equals x. So the x intercept is 0. Now same thing for y intercept, do x for y intercept, x value will be 0. So it will be y equals 200 into 0 divided by 0 plus 12. So it's basically 0 divided by 12. Whenever the numerator is 0, the answer is 0. Don't get confused. It's not undefined or anything. Only when the denominator is 0, when the denominator is 0, it's undefined. When the numerator is 0, it's just 0. So x and y intercepts are 0 and 0. You can see the x and y intercept 0, 0. You can see there's a point at 0 and 0. And then end behaviors are where the graph, or how the graph behaves. Look over here. As the x values are going towards negative infinity, what is happening to the graph? Y-axis. What are the y-axis values? Since it's an asymptote, it will always go towards plus 200. So as x goes towards minus infinity, y is 200, and same thing at the right side. As x goes towards infinity, the y value is 200. So this is how it works. So both the sides, it's 200 and 200. Now then, what next? Find the dosage for a 12-year-old child if the adult dosage is 200 mg. You can use the graph and do it, but the easiest way is in this equation. Now what they're asking is, what is the dosage for a 12-year-old child? Say this is 20, so 12 is somewhere over here. You need to find over here. It might be 100 mg. So what you do is just put over here the in this equation. Y is unknown. We need to solve for 12 years. So 200 into 12 divided by 12 plus 12. So you will get 2400 divided by 12 plus 12 is 24. Sorry, 24. Yes, it's 100. So 100 mg is the answer. Okay. So you can just substitute over here and you get the answer as 100 by 24. 100 times is 2400. So this is how you can easily solve this graph. They have whatever is asked, just look, see accordingly and solve it up. This is it. You can either check with the graph, say it's 12 is 100 over here, or you can solve it by substituting whatever x value they are given, because x is the age of the child in years and they have told 12 years. So that's the thing. Now here then, compare rational functions. Now in this question, they have given an equation and then given a graph. The graph and the equation are not the same. See over here, g of x is x minus 2 by 2x plus 2. The rational function h of x is given in this graph. We don't have the equation for this. Now we need to graph the given equation. See, x minus g of x is given, right? We need to graph that. So first thing, find the zeros, find the horizontal, vertical asymptote, basic things, okay? So what is the zeros? Make the numerator equal to 0, x is equal to 2. Now what about the vertical asymptotes? First, vertical asymptote, denominator equals 0. 2x plus 2 equals 0, this one. See, the numerator was this, and it's very simple. Now the denominator, 2x plus 2 equals 0. Take this 2 to the other side, it'll be 2x equals minus 2. Divide both the sides by 2, it'll be x equals minus 1. So what is the answer for the vertical asymptote? It's minus 1. What about the horizontal asymptote? Look at the degrees. It's 1 and 1, right? Degrees are same, so write the coefficients. What's the coefficient over here? 1 divided by, here it's 2, so y equals half. So that is the vertical asymptote is minus 1, horizontal asymptote is half. Now if you know the horizontal vertical asymptote, then it's very easy to draw the graph. We know it's over here, x is minus 1, y is half. Now this is how we graph it, and then take some table values. Take some values, say minus 2, minus 3, and 0 and 1. Put it in this x values, you will get this table of values, and you can plot the graph. Now this is just graphing, okay? All these 3 steps we just graphed. Now the most important thing is part B and part C, that is to compare. See, they have told over here compare, right? This type of problem is about comparing. Now which function has greater y-intercept? Let's look. What is y-intercept? When x is 0, that is y-intercept value. Over here you can see the top of the graph does not touch the y, so it's only the bottom, right? Here it's minus 2. What about here? Minus 1. Now which is a greater value? Don't get confused. Minus 1 is bigger than minus 2. Whenever it's negative, the smaller the digit, bigger is the value. So minus 2 is less. So this graph, which is this g of x graph, has greater y-intercept. It is g of x over here. G of x has greater y-intercept, and here it is lesser. And compare the asymptotes. What are the asymptotes at g of x over here? Vertical asymptote is at minus 1, horizontal is at half. G of x, vertical minus 1. Now let's see the h of x. Here vertical is plus 1. See, it's minus 1 plus 1. What about the horizontal asymptote? Here it's half, here it's 1. So these are the comparisons, the basic comparisons. And that's basically it, for this problem. It depends on what has been asked. Now you can see this problem here. They have told to consider the function g of x and the graph of h of x. We don't have the function equation for this. We have to just tell which function has higher horizontal asymptote. Now since they are just asking horizontal asymptote, what I'll do is I'll just find the horizontal asymptote. No need of anything else. How do we find horizontal asymptote? See the degrees. 1, 1. So write the coefficients. It's minus 6 by 2, that is equal to y equals minus 3. Now if you have minus 3, that means it'll be somewhere over here, the horizontal asymptote. Now what about this given function? Here the horizontal asymptote appears to be at positive 2. So which function has higher horizontal asymptote? It's the graph function, already graph 1, that is h of x. So the answer is h of x. Because here, just solve for horizontal asymptote, you will see the degrees are same and the answer is minus 3, which is below, down below. Whereas this has at positive 2. Not the vertical asymptote. If it was asked for the vertical asymptote, then all you need to do is the denominator. 2x minus 3 equals 0. It would have been x equals 3 by 2. It's 1.5. Here it is somewhere over here, negative 1.5. This graph, it would have been positive 1.5. But that is not the question now. It was only horizontal asymptote, which is h of x. Now then, so this still just now what we did was mainly horizontal, vertical asymptote. This is how normally we graph rational functions. This is basic rational functions. Now if we look at oblique asymptotes, now look over here, it's oblique. What does oblique mean? Oblique is something that is not straight. It's like a slant function, say like this or like this. That is oblique. A linear function, but linear function can be straight as well, but it's not those two. If it's vertically straight, then it's vertical asymptote. Horizontally, then it's horizontal asymptote. Now oblique is something, not these both, they are something like this, okay, slanted line. Now let's look at them. Now how do we find oblique? So oblique happens only in special cases when you can't factor the numerator and denominator and the degree in the numerator is exactly 1 greater than the denominator. Let me give you an example. If I have x to the power 3 divided by x power 2. Now this is not having oblique asymptote because it can be factored. Sorry for that. Now x minus 3 the whole, okay, I'm getting x cubed minus 3 divided by x squared. Now look at this. I can't factor these out. And the difference here is 1. See, 3 minus 2 is 1. Or if I have x squared plus 2 divided by x, the difference is 2 and 1. So exactly 1 must be the difference. Such cases you will have oblique asymptote. Then there is something called point discontinuity. Now what are these things, Now imagine you have x plus 2, x minus 2. Okay, the original function, and over here you have x minus 2. What is the vertical asymptote? Sorry, not vertical asymptote. What is the undefined value? Undefined value is at x equals 2, right? So x can't be 2. But look at this equation. This can be simplified further and written as x plus 2. So the graph is the simplified functions graph, right? If I graph this out, x plus 2, so it will be something, plus 2 will go up, it will be something like this. But we know that this function initially was undefined at 2. So where is 2? Somewhere over here. We just put a hole over here. Why? Because this function is valid everywhere except this particular undefined value. So this is called point discontinuity. We will look into both of these types of problems. So over here we can factor them out. See, it can be factored out and then we put the point discontinuity. Now let's see over here. Here you can see the degree, the numerator denominator cannot be factored out. I mean, let's see how it can be done. But anyways, the degrees differences by 1 starting is to find the zeros. Let's do it one by one now. Since it's a quadratic equation, you can use your calculator easily. How do you make this? How do you find the zeros? It's mod phi 3 and put in the coefficients. It's 1 plus 2, sorry, it's plus 2 and lastly 1. And now the zeros are minus 1 and only minus 1. That means you can see only x. There's no x1, x2. It'll be x equals minus 1. Take it inside. It'll be x plus 1 the whole squared. So this is simplified to x plus 1. See, you can't factor them out. So first simplify and check. Okay, we can't factor it out. So what happens over here is x plus 1 the whole square, okay? Or you can write x equals minus 1, that is the 0. But if you're writing in factors, you can see this is x plus 1 the whole square. So it is having, sorry, since they are asking 0, you can directly use the calculator, sorry. 1, 2, 1, put it over here, it's minus 1, that's it. Now that is finding zeros, right? That is like where the, if you have the graph like this, where is the x-intercepts, that's what it means. Now what about the next thing? Asymptotes. Let's find the vertical asymptote because it has a denominator. You can see over here x equals minus 4 is the vertical asymptote, okay? And what about the horizontal asymptote? Is there any horizontal asymptote? No, because the degree in the numerator is greater than denominator, so we don't have any horizontal asymptote. But in this case, you can see the degree and in the numerator is greater than the denominator just by 1, exactly 1. That means we will have to find the oblique asymptote. This is slant asymptote. So now here we need to do the long division. I hope you remember long division from grade 10 term 3, I believe. If you have forgotten, I'll put in a video in the description how exactly long division is done. So we need to do long division over here. If you have completely forgotten, if you're not understanding, try to follow what I'm doing over here. If you're still not understanding, then please go to the video in the description because in detailed long division method is explained there. So how it works is, see, this numerator divided by the denominator, whatever you're dividing, write it inside this this symbol, like you can say it like a half box, okay? And outside is whatever you're dividing, that is the divisor. Now you must multiply this first term with such a number that it will be equal to x squared. So over here it's very simple, x times x is equal to x squared. But what if it's a complicated one? Whatever is this term, x squared, just divide by this first term. It's x. So that's why we multiply this by x. And now you need to multiply both these terms with x. X times x is x squared. 4 times x is plus 4x. That's the step 1. Now you have to change the signs here. The signs changes to negative and this cancels off. That's our main intention, to reduce these terms. Now when it cancels off, you're remaining with these two. Here it's plus 2x minus 4x. It'll be negative 2x. That's remaining. Okay, that's done. Now bring this, since there is only a single term and your two terms, bring this last term down here. It'll be plus 1. Now what do you do? Minus 2x, the first term, same, repeat all these terms now. Minus 2x divided by x equals, this cancels, you're remaining with minus 2. So minus 2 is what comes up over here. Now multiply these two terms individually with minus 2 like distributive property. X times minus 2 is minus 2x. 4 times minus 2 is minus 8. And now this cancels, the sign changes over here since it's only one term, 9, and there is no terms to bring down. This is your remainder, this is the quotient. Quotient is the answer by division. So now you can see x minus 2 is what you get in long division. For long division method, for the asymptote, you don't need the remainder, so you just ignore that. All you need is this x minus 2. Okay, so here we will just see now one by one. You multiply x, x times x is x squared, and then 4 times x is 4x. Here you change the sign, and what happens? You're remaining, this cancels. Here also the sign changes, and this is minus 2x. Now bring this down over here, and now repeat the same procedure. What needs to be multiplied by to x to get minus 2x? All you need to do is minus 2. So minus 2 times x is minus 2x here, and then 4 times minus 2 is minus 8. Cancel the first term. See, these terms cancel out. You will get only plus 9y because the sign changes here. Minus minus becomes plus. And the answer over here is only the quotient, nothing else. That is x minus 2. So the horizontal asymptote, oblique asymptote, sorry, is at x minus 2. Now if you're graphing this, you will have to graph the two asymptotes. You can see over here, before coming to this ordered pair and stuff, The vertical asymptote you can see from here, x minus 4. That's fine. What about the horizontal asymptote? We found, how much was it? X minus 2, right? Yes, x minus 2. So you can see you have to graph at x minus 2. See, where is minus 2? Here. So graph a 45-degree line from here. That would be your horizontal oblique asymptote, a slant asymptote. It can be called a slant asymptote as well. And now just take few values less than the vertical asymptote. Take say minus 6, minus 8, just to get a brief idea. No need of so many values, just 2 values, and plot the points. You'll get these points and just draw a smooth curve. Now since there is oblique, it must be like this. The shape of the graph will be like this. Even over here, just take some 2-3 points, say minus 2 and 0 and 2, and just plot it like this. So that is how we graph these, graphing oblique asymptotes basically. So in this, long division is required. I hope you remember long division. If you've forgotten it, please go to the video in the description and watch it. It's a very short one. Just quickly watch it. You will understand long division. Now then, over here they are asked us to again a check problem. Now please do try solving this by yourself. Pause the video, try it by yourselves. Let's quickly solve it now here. What is the vertical asymptote? It is 2x plus 1. That is equal to 0. Take this 1 to the other side, it will be 2x equals negative 1, x equals negative half. So the first answer is negative half or negative 0.5. It's the same thing. What about the oblique asymptote? That means divide this 2x squared plus 3x plus 2 with the divisor. What is the divisor? It is 2x plus 1. Now what do I need to multiply? It's directly x. Or you can just do 2x squared divided by 2x. X, if I multiply, you'll get 2x squared. Now this just needs to be multiplied here. Change the signs. This cancels off and you're getting over here plus 2x. Now bring this down, plus 2x comes down here. And now what do you multiply to it? You need to multiply just 1 because you have 2x here and this is also 2x. Just add 1, it'll be 2x times 1, it's 2x. And this 1 times 1 is plus 1. This cancels. You don't need to do anything else. Over here, this is the answer. See, if it was higher degree, it will reduce 1 by 1. And when you reach constant, it's over. So here it is minus, so your remainder is 1, but this is not required. Your answer over here is just plus 1, this one over here. So plus 1, that's how you find it directly and easily. Going on, okay, now graphing. So this is the graph. What you do is take some values less than the vertical asymptote and more than the vertical asymptote. Now here x plus 1, so you can see at a 1 you draw a straight line, 45-degree line. Because when slope is 1, or you can just see the slope, x is 1, y is 1. So that's how you graph. 2 points you'll get, graph it off. Now then, over here, we are dealing with point discontinuity. This is the last topic in this lesson. What about point discontinuity? So you can see that question over there. What does it remind you of? You should know that you can use your calculator to solve. Otherwise, if you know this formula, a squared minus b squared equals a squared, sorry, a plus b, a minus b. So this is a formula. So now here x squared minus 4 can be written as 2 squared, isn't it? So a squared minus b squared, that is x plus 2 x minus 2. This is the answer. Or you can use your calculator here. How do you do it is more, and what is this? Quadratic, so it's phi equation and quadratic equation 3. Put the coefficient 1. There is no x term, so it's 0, and lastly we have minus 4. What's the answer? 2 and minus 2. So x equals 2, okay, and x equals minus 2. Bring this inside, it will be x minus 2 one factor and x plus 2 is another factor. This is how. Or if you know the identity or formula, you can directly write it. Now what happened over here in the numerator is x plus 2 x minus 2 and the denominator as x plus 2. In the previous oblique asymptote, this was not the case. You could not factor it out. Here you can. So cancel these two terms. You are remaining with x minus 2. So graph x minus 2, which is so easy. Wherever it's minus 2, draw a straight line like this, 45-degree line. This is at minus 2, or slope is 1. But what you need to do is, look, what was the undefined value? Take it to the other side, x is minus 2. So at minus 2, where x is minus 2, you must just put a hole here. That is how we graph it. Now we'll see. You can look at the graph. Wherever you have minus 2, draw a 45-degree line, or the slope would be like this. 1, x is 1, y is 1. Why? Because the slope is 1 here. And then draw the draw the line x minus 2 line, but remember to put a hole at minus 2. This is x minus 2, right? Because this is the undefined value. So first you need to simplify these two terms, then find the undefined. This is x minus 2, but what is the undefined value here? Denominator cannot be equal to 0, it's minus 2. So that's why the hole over here and the graph. So that's it. Very, very simple. Now even over here, you don't need to use calculator or anything. Why? Because it's direct over here. X plus 3 the whole square means x plus 3, x plus 3. This is the factors, and x plus 3. Cancel this term with the numerator and you're just graphing plus 3. At wherever it is 3, you will have a straight line. Okay, that's a very bad line, but you get it right. It's something like this. Now, what is the denominator? X plus 3. Make it equal to 0. What is the undefined value? Minus 3. So at minus 3, somewhere over here, there will be a hole. So this is the line must not pass over here. It's just a hole, okay? It's an empty hole. There must be no line passing. So that would be the answer. Over here you can see the discontinuity. Point discontinuity is where the value is undefined, is at minus 3. And the graph over here, okay, 1, 2, 3. Mine was not accurate. Sorry, it should come down, but I can't. I didn't do it properly. But here, 1, 2, 3. Draw a 45-degree line properly, and then 1, 2, 3, minus 3. That is the hole. And this is how you plot point discontinuity, graphing point discontinuity. Just remember, point discontinuity are undefined values in the original equation, but the final equation, this is simplified to x plus 3 only. So the graph is very simple, but there will be a point of discontinuity. So that's the end of this lesson. I hope you have found this useful. This was about rational functions. So rational functions is similar to reciprocal functions in few ways, that is horizontal and vertical asymptotes. I mean, the way you find it is different, but here you need to remember few conditions, and oblique asymptote is one more special case, and point discontinuity can happen in rational functions. And please remember long division method. If you have forgotten it, go down to the description and please do watch that. Thank you guys for watching the video. I will please do stay tuned. I will try to upload the next lesson as soon as possible. If you have any doubts, post them in the comment section. Bye bye and take care.